the introduction of the ESS, and second item is the ESS trend in Korea. Finally, I have to summarize. So I think the necessity of the energy storage system is same in all of the world because we have the same problem with global warming and energy efficiency and smart grid and electrical flexibility and safety. And also the battery can be possible to store the electricity compared with the other generation. So I think those kind of the point is our necessity of the energy storage systems. In case of the Korea, we are also to have several target of the global warming to reduction of the carbon dioxide generation, and also that we have to renewable integration with energy storage system. This is our new business model to energy part. So there are some example about case study about the DR market energy storage system combined with an energy management system and clean energy tower and some kind of the electric vehicles and solar PV inverters. So our government have to target to 2030 to reduction the 37% of the BAU. Also recently our government have
온실가스 배출 전망치를 낮추기 위한 노력으로 계속 진행될 예정인데요.
When we can reduction the carbon dioxide, so 2030, finally we have 2050, we have to start to the carbon generation. So Korea government very strong target to promote the renewable energy and EV cars and storage system and some other things. So before I mention about the energy efficiency, it is the same situation of all over the world, and in basically advanced country, they have some unbalancing in demand and response in nighttime and peak time. So this is another goal to use the energy storage system to compensate to this energy balance. So when we are using the storage system to store the electricity in night times, and then it can possible to use in peak times, normally in daytime or night times. Another approach is smart grid. That means our grid system is more advanced to operation and harmonizing to the power generation supply side and customer side. So in that case, we need the storage system can be possible to some business model to selling to the electricity to buy from the customer side, with including using to the solar PV and some other power generations. And recently, I researched for some electrical feasibility and safety. So 2020 and 12 we have several blackout because depend on the various kind of the regions, like the climate change issues, and to use the energy storage system can be possible to prevent our safety use to the electricity. So this is a configuration of the energy storage system. So battery energy storage system can be operating by the energy management system and connecting with the PCS, connecting to the grid. Sometimes it can be possible to the harmonizing with the other power generation like the renewable energy, case of the solar PV, wind powers. So you can see that some several standard model about the containers and building blocks. So this is another business model in the Asian Development Bank. They have published the handbook of the battery energy storage system. It is possible to the storage system installed in developed country for frequency regulation and renewable integration and peak shaving and road levelings. In case of Korea, we are starting 2012 to install the energy storage system in our building and factories to reduction the peak. This is the first subsidized program in Korea government. So after 2016, we are starting to kind of subside combined with the solar PV, it around 0.0 REC to store the electricity, and then they will supply for the grid, and after solar down. And then 2019 and 18, we are growing up more than 3.8 gigawatt hours per year. So this is almost 30% of the global market shares. But we are still developing our technology to increase to the voltage, because the storage system capacity increased more than 100 megawatts capacity. Also, the power rating is also increasing to the more 200 kilowatt hours. At that time, so we are considering some wider issues. So our government, we are made some production standard and installation standard and operation management. And also we are still developing to the fire standards. But you can see that the fire standard came from the US. Before 2018, we don't have any fire code about the energy system to installation in the building or containers. But right now we are developing the fire code to installation, operation, and management. And in Korea government, we are planning for to the next program to the public energy storage system. It's similar with to the frequency regulation to install the substation. So, and in eastern and western areas, we will install the 1.4 gigawatt hour storage system. It is around the 10 billion US dollar. And first years, we are expected around 500 megawatt hour system in this year. And next years, we will expect around the 900 megawatt battery systems. Also, in special area, like the Jeju Island, we have some renewable curtailment, because that in that island, the renewable generation rate is increased more than 20%. At that times, we are some renewable energy generation curtailment. So Korea KEPCO, and they will install the storage system to store electricity during to the curtailment. So that is the most common application to microgrid and some offshore wind turbine connection with to the grid. And also our association, we are have some responsibility to how we can approve to the storage system safety and performance. So right now we are considering to some KC certification by the battery. It is certified by themselves. So manufacturers, that means the manufacturers on EPC, they have their own certification to approve their product safety and performance. Okay, thank you for kind listen.
Thank you so much. Thank you, Dr. Kim. So we leave the questions time in their Q&A session. So let's kick off our next presentations. Our last panel discussion, and the panel moderator, we invite Mr. Vincent Baker. He's a Group Controller from Interior Energy, and Daniel Manuel from SGCIB. He's a Managing Director, Head of Natural Resources and Infrastructure Asia Pacific. And Brett Kim is Managing Director of Stonepeak Infrastructure Partners. Welcome. Hi, I leave my floor to you, Vincent.
All right. Thank you very much, Jessica. It's always great to be invited by the beautiful PV Box team. My first question, can everybody hear me?
Yes.
Okay, very good. Well, welcome everybody. My name is Vincent Bakker and I'm with Antoria Energy. We are a renewable energy developer that is active in Latin America, Southern Europe and Asia. Now, I've looked a lot into renewable energy credits and storage, and I'm very excited about this very new market. And I learned a lot from Professor Kim's story. but a lot of things are quite new. So my objective today is to get some great insights from our two experts and to answer any questions from our audience, but of course not give our experts a too easy time and not shy away for difficult questions. So I'm happy to be joined today by Brett Kim. Brett Kim is the Managing Director of Stonepeak Infrastructure Partners, active in investing across the entire infrastructure range. And I'm very keen to get his views how storage and RECs fit in the infrastructure investment landscape. Hi, Brett.
Hi. First of all, it's good to be here. Thanks for having me. Sorry, did you say how RECs and storage fits within infrastructure space?
That's one of the questions that we're going to answer soon, Brett. But I first also would like to introduce our second panelist, Daniel Mallow. Daniel, good afternoon. Daniel is the MD and Head of Natural Resource and Infrastructure APAC for Société Générale and did a lot of deals and especially debt financing across renewables. So also very keen to get his perspective on financing. Welcome, Daniel.
Thank you, Vincent. Good afternoon, and looking forward to the discussion.
Okay, Brett. Well, you were very eager to bite it off, so I'll give the floor to you. What do you see in the market for storage and RECs as a private investor group?
Okay, it's quite a tricky question because I think there's actually two questions in that. Starting with, I think perhaps the easier topic on ESS. The world is going through a huge energy transition, moving away from fossil power to renewable energy. Obviously, renewable energy is characterized by the intermittency of generation, which also then means that there's going to be a lot of issues in the grid and the availability of a stable load. And because of that, and there are experts here that know a lot more about how these work than I do, but I think ESSs and storage systems generally have a huge role to play. Dr. Kim spoke about the ESS market in Korea and the various plans for a very large public ESS, for example. And it's going to be a critical component to the future of the electricity markets around the world. Separately, RECs, renewable energy certificates, it's a relatively unique feature of the Korean renewable energy market. And I think there's again a lot of experts on this call who know more about this than I do, but it is something that's made Korea quite a different market to the rest of North Asia, such as Japan and Taiwan, which are based on the feed-in tariff and the long-term PPA with a fixed price. RECs, I think going forward, will continue to play a significant role in the Korean renewable energy space. But at the same time, with the introduction of a corporate PPA regime under the recent amendments to the electricity business law, I do think that there's going to be a reducing emphasis on the RECs in the Korean market and a growing emphasis and focus on the corporate PPA side.
Okay, thank you very much. Daniel, yes, as Brett said, storage will be essential for a higher renewable energy penetration. Where do you see the financing options coming in?
Yeah, absolutely, Vincent. I think storage will play a key role, and in a lot of ways, like Brad said, storage is the holy grail for renewables because it gives you the ability to transform that intermittent source of generation into something more akin to a baseload source of generation. So it is a huge value creator, and maybe the value bifurcates into several segments, and maybe we can take a leaf of where we have seen storage being deployed in other markets in the region, and why it has been successful, if it has been successful. And if we travel for a second to Australia, for example, we have seen in Australia several large-scale renewable energy generation assets coupled with large battery storage. One transaction that we've been involved with is a 300 megawatt wind farm in South Australia, coupled with a 100 megawatt battery storage solution provided by Tesla that's been operating for a couple of years now. And what have we observed? Two things. Very valuable from a grid stability standpoint. And Australia has had its issues with related to the grid, and the ability to smooth out the output of that large wind farm through the storage solution has been very valuable from a grid stability standpoint, and it's been noted and appreciated by grid operators in the system. So I think that is an important component. As you have more intermittent capacity entering into a system anywhere in the world, there are issues around the grid, and storage can be a critical part of the solution. The second element where it's been very valuable also has been in economics. Australia is a deregulated market. You have a spot market in which you can sell electricity, and the ability to use storage to optimize returns has proven very profitable. Now, that's not the case everywhere. Other markets in the regions are closed or dominated by an incumbent or a monopoly, in which case it's a bit more difficult to extract that kind of value creation when you're in a closed market. So to me, clearly storage will play an increasing role. It will be most valuable in open deregulated markets. Now, how do we look at it from a financing standpoint? And there again, maybe it bifurcates into two models. How do you get paid for your storage assets? And are you generating revenues solely by dispatching into an open market, in which case you're really subject to additional revenues, but revenues with a high degree of volatility. And again, Australia is a good example. The volatility in power prices is substantial in most of the country. So that makes it a bit more difficult from a financing standpoint to look at reliable, stable cash flows and to extend financing against that? Or do you get paid a capacity payment, an availability payment, a more fixed kind of revenue stream, in which case it looks a lot more like an infrastructure type asset, and it's a bit more conducive to finance on a standalone basis. So to me, there are several variations. Clearly, storage will play an increasing role. There's no question in my mind, but there are several variations in the way to set it up and in the way to finance it.
Well, Brett, that's interesting, but I just heard that Capco is buying all the storage and they're doing it themselves. Is there any room for private investors in Korean storage market?
Sorry, is that for me?
Yes, for you.
All right. That's a great question. Actually, we discussed this with a lot of people as to whether there really is space for private investing in the storage space in Korea. I think it's interesting in the sense that over the past few years, there was regulation which specifically gave the private sector the opportunity to invest into and develop storage assets, both behind the meter and also connected to renewable energy projects themselves. The subsidy arrangement for both of these models have now ceased, and it's quite telling that accordingly, there's no storage assets that are being developed by the private sector anymore. And at the same time, whilst there's rumors of new subsidies or new regimes being developed by the government, at the same time, Capco has announced this very large grid-connected ESS to provide a certain connection and reduce the curtailment risk. So I do think it's going to heavily depend on where the regulations and Capco's plans for ESS ends up. On the one hand, as the monopoly grid operator, Capco maintaining their control, ensuring that there is capacity within the national grid system to meet the future renewable energy volumes, is going to give the market a lot of comfort and certainty. But at the same time, you should also ask, is there the possibility of really growing the business, encouraging a higher level of private sector innovation in the space by giving the private sector the possibility and the room to invest into this space as well? I think the jury is still out. A large part of it, I guess, is because of the multiple fires that have arisen as the result of the very widespread promulgation of the ESS. But going forward, look, who knows what the answer is, to be honest. I'd love to see, look into the crystal ball and find out what the answer is myself, to be honest. But yeah, I think the room is definitely there, but will be heavily driven by where the regulations end up.
So a big question mark, it sounds, because indeed that's an interesting point that we raise here. Where's the business model? And Daniel already touched upon that. And that also ends to your comment, Brad. It's not clear if there will be a private market role. Is it going to be on a capacity charge basis in which I basically install and rent out my battery? That might be difficult to secure long-term contracts. Can we do it based on arbitrage, so using the battery to buy and sell electricity? Or is it maybe to prevent curtailment? I know my solar farm will be curtailed, so I might as well invest in batteries myself. So those are apparently the different scenarios that we run into. What other business models do you see? Do you see a business model that KEPCO can? Because of course, if KEPCO wants to have private parties for the grid stability, how do you price your volatility payment? How do you price your capacity charge? How do you price your frequency control? I think that's very difficult. Daniel, do you see any learnings from for instance, Europe, where these contracts are a bit more common, maybe?
Yeah, I think it boils down, Vincent, to ultimately someone has to pay for it, right? And it's an investment. It comes at a cost, and as I said, grid stability is a good thing. It's a good thing for everybody. It's a good thing for the regulator. It's a good thing for the transmission operator, and it is a good thing for the generators. But somebody has to pay for the investment. So is there room to outsource it to the private sector? Absolutely. I think there can be a model set up where the private sector is enticed to incur those investments and gets remunerated for providing that grid stability service. So that can be in the form of a long-term contract under which you get a capacity payment and you provide an essential service to the grid. I think that would be conducive to attracting third-party investment to develop those investment solutions. But there has to be a way to pay for the investment. So either to generate revenues on a standalone basis or to be remunerated for providing an essential service to the grid.
Now, Daniel, would Société Générale consider debt financing for storage projects that work on frequency control, for example? I know there's countries in which there's a frequency control market where you can rent out a capacity charge, but the market price is not certain.
Yeah, I think that's the key, right? I think just like for any renewable energy asset, I think the key to raise debt capital is to have some level of predictability of revenues. And of course, full predictability can never be achieved. There's always variables around production profiles, potentially around pricing, or to some extent. But you need to have some level of stability around the cash flow generation capability of an asset. Otherwise, it is difficult to extend large amounts of capital against it. Frequency charges in other markets, we have seen them as being very to extremely volatile. So that is difficult. Predicting the behavior of those cash flows over any extended period of time is almost impossible. So on that basis, it is a bit more difficult to extend capital on a standalone basis. So what are the other alternatives? The other alternatives are to blend the battery storage with generation assets and finance them as an ensemble, as a whole. And there, in those kind of situations, the cost of the battery is really an add-on to the rest of the generation assets. So essentially, you end up financing a large wind farm or a large solar plant that happens to have a battery sitting next to it, but you combine the investment, and in essence, you finance the investment on the battery essentially through the PPA associated with the solar plant or the wind farm. So that is a variation of the model, for example.
Okay. Thanks. Now let's zoom in a bit more on Korea. Now that we had some discussion about the global storage options. Brett, what do you see happening in Korea? What are the most interesting renewable energy plays for you in the coming 12 months?
Near term, the stuff that excites us in Korea would be large-scale solar. So there's been various changes to the regulation which support the recent electricity plans, as well as the government's commitments to net zero carbon by 2050. Some of these include the utilization of high salinity agricultural land for large-scale solar projects. So we do expect that there will be more of these projects reaching FID/NTP in the near term. So those are exciting. I do think there's going to be quite an exciting future for floating solar in Korea as well. So that's another area. And particularly, I'm looking forward to the first generation of commercial scale offshore wind projects coming to market. So that market in Korea was announced quite a long time ago. It's a decade-old sector in Korea. But apart from a small number of small offshore wind projects, there's not been any large, truly commercial scale offshore wind that's been developed in Korea yet. But I'm hearing that there's going to be a few projects in the Jeolla province that are hoping to reach FID towards the end of this year, early next year. So over the next 12 months, really looking forward to seeing how these deals shape up and how they will be, I guess, kickstarting the sector as a whole in Korea, but how they'll be different to the other markets around the world in terms of how they're structured and how they'll be tailored to meet the Korean requirements in terms of local contents, how they'll make use of the very large strategic investor base here, as well as the financial markets in terms of being tailored for the specifics here, as opposed to just following what's happened in other markets around the world.
Okay. Yeah, large-scale solar, of course, that's nowadays has the lowest levelized cost of electricity. Offshore wind, expensive. It's taking off in Vietnam, and half of the world is flying to Taiwan to make it happen. Why is it not taking off in Korea? Where's Korea's offshore wind? What's holding it back?
I think there's a number of different factors. On a more physical level, it's not an easy market for offshore wind. Wind is not very strong. In many places, the ground conditions are pretty challenging. And in addition, there's been challenges with grid connectivity as well. So it's not the easiest physical conditions to get this happening. I think on a more macro level and on a market level, since Korea announced its offshore wind ambitions over a decade ago, there's been a few market events which made it very difficult for that drive to continue. So offshore wind was intended to be the new sector to deliver industrial growth, especially to the metals and the shipbuilding industries in Korea. But with overall delays to the sector, there's been a lot of companies that have come and gone in the space, which has led to delays in these deals actually getting started. And I think at the same time, the lack of a unified offshore wind regulation has made it relatively slow to start. So I think if we look at other markets in the world, or nearer to Korea, for example, in Taiwan, there was a very clear government legal framework to kickstart offshore wind. There was a clear bidding process to award licenses. We're seeing a similar move in Japan, but in Korea, it's being discussed, but it hasn't actually happened yet. So I think it's a combination of these factors which has led to offshore wind being a relatively slow starter. But at the same time, I guess the benefits of being a little bit slower to start is that Korea's had the opportunity to learn from other markets and their stories on the offshore wind journey. And accordingly, Korea has actually been able to prepare a little bit better for it. in terms of both having a lot of localized supply arrangements and a lot of suppliers who can actually supply to the sector and have experience in doing so globally, and also having the ability to finance a lot of these, having a lot of very large investors and financiers into the space overall.
Okay. So yeah, that's maybe an opportunity in the future, right? You can very easily copy the learnings from other countries and achieve the same at a much lower price. But yeah, a non-unified framework that sounds scary to foreign investors if there's no clear framework, because of course foreign investors, they like to open the rule book and know exactly how things work. Daniel, in your perspective, compared to the other markets, do you think Korea is an easy market to enter? And if so, which sector is the most convenient for foreign investors? And what are the challenges that they face?
Yeah, and I think maybe just to piggyback off Brad's comment, I think offshore wind will happen in Korea. Maybe it's taken longer for a variety of reasons, but I think it will happen. I will bet you, Vincent, that we'll see the first offshore wind farm in Korea before Vietnam. As much as there is a lot of activity and prospect in Vietnam, I will bet you that Korea will come out ahead ultimately in terms of first turbines in the water. I think it will be similar, but also different to other markets. I take your point, Brad. We will have learned from other markets, but I think Korea, and I take your point also on the topography and the sea conditions. But I think as a result of all this, Korea could well emerge as the leading market for floating offshore wind. I think it has a lot of the ingredients to really jumpstart that sector, that subsector of the offshore wind space. So I think there are exciting times to come. And to me, it's no accident that most every large renewable energy, global renewable energy company has opened offices in Seoul over the last year or two, in large part with their eyes on the offshore wind sector. Thirdly, I think this time it needs to happen because there is more urgency in energy transition, and the one thing that offshore wind brings is scale. Is a clear acceleration of the energy transition, and land is a little bit of a consideration in Korea. There's only so much you can do in terms of very large scale solar or very large scale onshore wind. So I think if we put all those components together, greater urgency, restrictions around land, and the final thing maybe that held the industry back a little bit maybe is that desire to develop technology domestically, which, you know, it's always a good idea to try to develop a technology domestically, but there's no shortage of bankable, reputable offshore wind turbines available in the marketplace. But I think this is all now starting to come together, and maybe 12 months is a little bit short your time horizon, Vincent, but shortly thereafter, I think we will see real strides being made in that market. I also want to piggyback off Brad's comment on floating solar. I agree with him absolutely, and I think that is actually again a sub-asset class in which Asia is likely to lead the way globally. We see more things getting done at the moment in floating solar in markets like Taiwan, Indonesia, across the region really, than in any other part of the world. So that's also an exciting sub-segment of the renewable energy spectrum, where Asia is actually ahead of the curve and is leading Europe or the Americas for that matter. Now to your question on penetrating the Korean market, it will not be easy. Korea is the energy market in Korea is very insular. It's very domestic. It is probably more difficult to penetrate than markets in India or Indonesia, Australia. There is no shortage of capital in Korea, domestic capital, both on the equity and on the debt side. So what will be required really for international investors to find a pathway into that market I think technology can be a differentiator. And again, if I go back to my floating offshore wind segment for a second, there hasn't been much that has gotten done in the world to date, but some Europeans have an edge and have developed some projects in the UK, in Portugal, and bring knowledge, bring technical knowledge, and that could be valuable as a foray into a new market like Korea. So I think technology, industrial expertise are probably things that will be required in terms of finding a pathway into the Korean market, and then forging partnerships with some of the local investors, local developers. I think this is the way I see it play out a little bit in the Korean market.
Yeah. Okay, very good. Yeah, you mentioned the technology, right? That certain technology can be brought in. Maybe two questions, and preferably a bit of a short, concise answer on this one. What do you think? Do you think the LCOE at this point in Korea is at par with international standards, or is there a lot of room to decrease costs? And secondly, which technology do you think Korea can benefit most from what's available abroad? For both of you.
I'm happy to have a go and look to Daniel to help out as I get lost in the answers. I think the LCOE in Korea is in line with other North Asian markets. If we look at solar, because I think that's the most comparable technology in the renewable energy space across different countries, deals that are getting done now, doing so at S&P plus REC contracts at around 12 to 15 cents per kilowatt hour, which is somewhat similar to what we're seeing in Taiwan and Japan as well. So kind of similar LCOEs. Where we're seeing changes to drive that price down in the solar space in Korea, firstly, scale. Just being able to build a much larger project than the usual size will help a lot. And increasingly, we're seeing some positive impact in reducing the LCOEs from the larger panels, bifacial, the use of more expensive but more efficient technologies like single axis trackers to really drive the optimization of the output.
Okay.
I think is really helping.
Daniel, what are your views? What is the LCOE like, and which technology should we import?
Yeah, I completely agree. I think scale and technology will help improve things. And I completely agree with Brad. Bifacial panels, trackers. The days of cost reduction on the panels is coming to an end, or has come to an end for that matter. So it's technology will have to substitute in rather than the commodity price reduction per se. And then scale. And that's what offshore wind will bring. Some of those machines are now pushing 12, 14, 15 megawatts a turbine. So I hear you, it is expensive, and it is always expensive when the industry is getting born. But over time, those costs come down, and we've seen that in Taiwan. Taiwan has gone from 0 to 2,500 megawatts in less than 3 years, and we've already seen the costs come down significantly, and I think that will be replicated in the Korean market.
Okay, very good. Because if Brad tells me that the costs are in line with the rest of East Asia, like Japan and Taiwan, what I hear is that's a very high LCOE when it comes to solar. So it sounds like there's some room to achieve in skill. I think we're coming to an end of this panel. I think we had a really good discussion about the status of the industry. Now it's time to look forward, and of course we look forward with some bold statements. Now Daniel already just put a bet on me, so whenever you're in Singapore in 12 months' time, we can see who buys the beer. Whether the first offshore wind is live in Vietnam or in Korea, the verdict is out. But I'd like to end this panel with two questions to both of you. The first question is, if you can run the Ministry of Trade and Energy for one day in Korea, what is the one thing that you would change to Korea's policy? And the second thing is, can you make one very bold statement that we can test when we are together in the same panel next year?
I'll let Daniel go first.
Okay, so I'm not Korean, so I may take a little bit more of a leap of faith on the policy making. I won't have as many repercussions as you might have, Brad.
Thank you.
But to me, policy making matters. Policy making matters. Things like feed-in tariffs do play a role to jumpstart an industry. You know, sometimes people think too much along the lines of subsidizing, but it is really a good policy tool to jumpstart an industry, and then capital flows. Capital follows, and things will optimize along the way. We've seen that in Japan, we've seen that in Taiwan, we've seen that in a number of markets. So it is the policymaker has a role here to jumpstart an industry, and in the context of offshore wind in particular, given the scale, that's something to keep in mind. A bold statement. For the next 12 to 24 months, I think we will see more than one offshore wind farm starting construction, and it will include international investors, not only Korean investors.
Very good. Thank you, Daniel. Well, Brett, you had time to think, so we're looking forward for a very good answer.
Unfortunately, Daniel's taken both of my answers, so I might temper the first.
That's the risk of going second.
Exactly. Especially behind Daniel as well. Look, I think in terms of the first question, I do think a feed-in tariff or a PPA structure could help, but Korea is already very well developed in terms of the RPS and the REC mechanism. Where I would like to see some bold moves would be in implementing the corporate PPA structure such that it is actually actionable by the various entities in the space, and more particularly, you know, what are the answers with regards to grid usage, grid loss, how to pay for all of that, and how would that actually work with all of the RE100 companies that are coming to market? You know, how can you trade the green power? So just setting up that RE100/corporate PPA framework in Korea, I think, is going to have a very large impact on the market and its growth in the future. Big statement for the next 12 months. Look, I echo Daniel. I think it is going to be the first commercial scale offshore wind reaching NTP. And I would actually like to also venture to say that there's going to be a greater than 100 megawatt solar project with a corporate PPA that gets developed.
Very good, very good. Well, thank you very much for your time, Daniel and Brett, and for the great discussion. And we'll look forward to celebrate the spud date of a few wind farms as well as the first 100 megawatt PPA. Back to you, Jessica.
Okay, thank you so much. Thank you all for the brainstormed discussions. Now we turn to our Q&A sessions. And first, we would like to invite Mr. Kong Song Park. We have some questions for you. Are you able to turn on your microphone to answer these questions?
Okay, good afternoon again. So the first question is, what is the gap between the potential solar available and the carbon? Yes, it is true that there is a huge gap, as I explained in the beginning. But collective and the collaboration or engagement of all the stakeholders and the resources will help the gap is to shorten the gap between these two. So it's not easy to elaborate all the measures and in short sentences, but all resources or most of the available resources needs to be put together so that we can reach our target. It's not an easy target, but it can be reached with appropriate endeavors by all the stakeholders and resources. That might be the answer for the first question. The second one is REC price is getting lower in Korea. Any support? So as by nature, the REC price is based on the allocation of the capacity as well as the market price. So it needs to be fluctuated according to the demand and the supply. But as I showed you at the last slide, the REC cap was upgraded or expanded from 10 to 25% at the October of this year. So there will be definitely 150% more demand in the near future. So I think the price will get back to or at least the direction will be changed at the end of this year. Yeah, that can be the estimation. But for example, at the time of FIT, the construction cost of 100 kilowatts was around 600,000 won. But at the time of RPS, the same capacity, 100 kilowatts, cost 200 million won per kilowatt, 100 kilowatts. So as we can compare these two huge gap between the construction cost and the price of the components of the PV system. So these all affect, or including other fuel prices, all together affected the lower price of REC these days. But it may be changed. It will be changed. What I can say that it will be changed. The direction may be changed. So that might be the second one. The answer for the second one. But the last one is yes, it is true that there are against all odds. So there are issues, people around the power site. But the agricultural solar is in the beginning stage. So we have we have several measures to cope with these difficulties. But it is I can assure you that this is not an easy issue, since this is about the opinions of many different residents and people. But in the long run, or as time gets further, as time goes by, there will be an agreement or consensus can be reached at some point of time. Maybe I can say at this point about this one as such. Thank you for
Thank
the
you so
questions.
much. Thank you so much, Kim. We turn to our next speaker. We have got questions for Dr. Kim. Hey, Dr. Kim. Hello, Dr. Kim. Yes.
Yeah, can you hear me?
It's your turn.
Yes. Yes. Actually, the solar system prices are still higher than other generation equipment. So I think the $500,000 per 1 megawatt hour battery system is compared to the other battery application like EV cars and some other things. It's still expensive than the other battery system, but I think the market is not bigger than to the EV car. So I prefer to the when the storage system price will be down. It goes by to the some government policy about the incentive and some renewable generation target increase of the renewable generation target around the 30% or 50% or net zero? Can you show me the question? Okay.
Sorry, I just
it's okay.
yeah, jump out regarding on the networks. So I'm gonna share the screen again.
Yes. So in my opinions, the battery cost is of the energy storage system, it will be same price with the EV cars. So the target is around less than 100 US dollar per kilowatt hours. But right now, I mentioned about the 500 US dollar per kilowatt hours. It is the 3 times higher than other battery applications. So when we will increase the energy storage system business in Korea, at more than 1 gigawatt or 2 gigawatt, then the price will be down around the US dollar per kilowatt hour. That means 100,000 US dollar per megawatt hours. The second question is the key technology in the battery safety. So, in my opinions, the BMS is most important to controlling to the battery system. So, almost the battery can manage by to the BMS, but there are no BMS international standard or some regulation or codes. So I prefer to the correct BMS can be prevent to some event from the batteries. So I hope our association already published the BMS standard for our association and to help to our storage system installation in Korea. So we will suggesting to the international standard to testing to the BMS a kind of the software and hardware and some abuse and environmental issues. So I prefer to when the BMS is most safe than other device, then it can be possible to the more higher safety storage system or battery system and other applications. Thank you.
Okay, thank you, Tim. So we turn to our next questions for Mr. Hangu. Mr. Hangu, are you still here? This question for you.
Can you hear me?
Yes, we can hear you.
Yeah, check the voice. Okay.
Hangu, could you please close to your microphone in order to get the clearly voice?
So we all know that the Korea currently the government or the local company encourage the development of the PV system to use solar power to power the so I think the market will be booming in the future, just like Mr. Kun's introduction, that the PV inverter will be the booming industry. And we also learned that there is a certification standard called KIC.
We lost your voice. We lost your voice.
Hello?
Yes, it's clear. It's clear.
Oh. Okay. There is a local certification system that called KIC 8565 for the inverters. So every company, if they want to enter the Korea market, we must get the certification. So our group has prepared the certification business since 2020. Also affected by the coronavirus last year, some job was delayed, but we have got our factory examining process last year. Then some basic testing for the inverter will be ready in this June. So our on-grid inverter will be ready for Korean market soon. And as for our plans, we have shipped our off-grid inverters for Korean market. And This year, we will mainly promote our 20 kilowatts, 36 kilowatts, and the 50 kilowatts. Also include our, just like my introduction today, the new max generation LV and the HV inverters for Korea under customers. So that's our plan for Korea market.
Thank you so much, Han-Woo. Hi, Mr. J. Now we kick up your question time now.
Hey, hi, Jessica.
Yes, we can hear you.
Okay, actually, I was looking for the question for module side, but yeah, this is a really tough question. The first answer to the first question is I think it's the answer can be, the greatest challenge can be vary, depending on who is asking for this question. For in general sense, the greatest challenge, for the renewable energy in Korea, that I want to say like it could be like a policy or the land acquisition, something like it. But what I'm thinking is the localization of this project, because the local acceptance of the project is very strong. I mean, very important. Which means the accepted by the local residents for the projects, especially for the utility scale projects. Because to find a way to cooperate with the residents or local residents, it takes a really long time. Even even because of this problem, even the development stage could prolong to like 2 or more than 4 years. So what I think is, what my answer is that the greatest challenge for the Korean renewable energy is the local acceptance by the acceptance by the local residents. That will be the greatest challenge. This applies to the PV plant, wind plant, hydrogen power plant. It is common sense. Yeah. Those projects.
Okay.
So yeah, and my second answer to the question, yes, the Korean the land situation in Korea is really tough. What can I say? Like almost 70% of land is mountain, and then the government they prohibit the developing land, the land use. So out of 30% of the total land, we have to find a way to use not only land, we also have to find the way to use loop, even on the water. There is the solution we could approach. But recently recently the Korean government, the land and infrastructure, what's that? I forgot the abbreviation, but recently the Korean government they initiated the projects for using the rail station, even the vehicle, the station. Also, the government they try to use the highway resource, such as the extra area, then the area beside the highway, even the resting area in the highway. So even those two the projects that could add up to like around 700 megawatt, it will be there, and the government is trying to complete these projects in 2-3 years. So that this kind of the opportunity is still open. So yeah, it's not the only the limitation of land. There's the trying to find the chance to develop the projects in the various way. I think that's the solution. And then I think the second question is related to the first question, because having the acceptance by the local, there will have a much more chance to develop even the utility scale projects. That's I think could be the yeah.
Thank you. It will make sense. Thank you so much, Jay. I think I would like to give more time for Mr. Braid, are you still there? And Daniel?
Yeah, I'm still here.
Yeah, I would like to give some time for our audience. If we have any questions, please raise your hands. I'm gonna give you a chance to ask questions to our speakers. Anyone who is raising your hands, and we can just check the questions on site. Sarah, okay. Okay, Sarah? Sarah, I think you can share your questions.
Hi, thank you. Yeah, I asked the question in the chat box, and thank you for somebody for asking it in the main question about how easy it is for foreign investors to actually invest in Korea. And the answer was actually very similar to what I thought it was going to be. But the answer about technology being the thing that you can bring as a foreign investor, are we seeing much in the way of very new technologies being interesting in Korea? The kinds of things that are at the pilot stage. Are there grants and other things available for pilot projects to like anything in the ocean or the non-traditional stuff that we haven't talked about today? If anyone's got any insights, I'd be really interested to hear them.
It's a good question, and to be honest, we've well, personally, I've seen a few of these grants being provided by both governments as well as other bodies. For example, in the offshore wind space, I know that there's a lot of pilot projects on the floating side that are being used in various parts of the country. In the similar space, I know that there are, for example, a different type of foundation that are being tested under a grant. I've heard of a tidal power generation system, which is being trialed in parts of Korea as well. So I think there is quite an active support mechanism for these pilot projects. On a bigger scale, I guess what's been announced in the hydrogen space in Korea can almost be seen as a way for the market to develop the technology as well, because Korea is probably the only place in the world right now where there's been a subsidy of sorts being provided for gray hydrogen fuel cell. And this is going to provide the developers in the market a great opportunity to work on a commercial scale fuel cell and really hone and develop the technology for future use when other cleaner forms of hydrogen are available as well.
Thank you so much. We have got one more question from our another audience, Mr. Bai, right? Are you able to turn on your microphone and just address your questions?
안녕하세요. 잘 들리세요?
네, 잘 들립니다.
네, 제가 영어 잘 못해가지고 한국말로 질문하겠습니다. KS 인증 있잖아요. KS 인증 왜 이렇게 언급한 건가요? 이거 좀.
그거는 네, 그거는 제가 죄송하지만 제가 뭐 이렇게 답할 수 있는 질문은 아닌 것 같습니다.
예. 연약하면 그 KS 인증 너무 언급해가지고 다른 나라 회사 그렇게 쉽게 한국 시장에 들어갈 수 없는 상황이에요. 그래서 제가 생각해가지고 이런 질문을 하는 거예요.
예, 잘 알겠습니다. 죄송하지만 뭐 제가 이렇게 잘 아는 분야가 아니라서 확인이 쉽지가 않습니다.
또 전번에 한국 화재 났잖아요. ESS 스토리 그에 대해서 좀 말씀해 주시면 좋게 할 수 있을까요?
어떤 부분을 말씀하시는 거죠?
한국 배터리 화재
네네.
그에 대해서 좀 말씀해 해주시면 좋겠어요. 그 며칠 전에 그거 화재 났잖아요. 그거에 대해서 좀 알고 싶어가지고. 예.
이 부분 역시 저보다는 아마 그 KBIA의 그 김 부장님이 아마 답해 주시는 게 좋을 것 같습니다. 아직 계시네요.
Can you speak Korean? English?
아니요, 저 한국 사람 아니에요. 중국 사람인데요. 그래서 한국말 좀 할 수 있어요.
케이시 등이 언급한 건 앞에서 제가 질문하신 거에 그 답변을 드린 것처럼 그 화재 이후에 배터리의 관리를 철저히 하기 위해서 인증 규정이 좀 심해진 거고요. 2018년 이전까지는 그렇게 강하지 않았습니다. 18년 이후부터 화재가 나고 질문하신 그 ESS 화재 인증에 대한 부분은 국내뿐만 아니라 ESS 가장 많이 설치되고 있는 미국에서도 엄격하게 관리되고 있고 UL의 프로포케이션 시험을 하지 않으면 판매가 할 수 없을 정도로 되어 있습니다. 그래서 한국만 그런 건 아니고 다른 나라도 다 강화가 되고 있다고 말씀드릴 수 있고요. 화재 관련된 내용은 그 케이스 바이 케이스입니다. 뭐 다 화재가 나는 것도 아니고 일부가 나는 거기 때문에 그건 이제 운영상에서 최대한 배터리를 많이 사용하다 보니까 그런 문제가 좀 생겼다고 얘기할 수 있습니다.
네, 그래서 그 배터리 때문에 그 화재 난 건가요? 그렇게 이해하.
그거는 네 맞습니다. 예.
네, 알겠습니다. 감사합니다.
Okay, thank you so much. We got one more audience, Mr. Liko, right? I think.
Yes, hello.
Hello.
I was wondering, before on the panel you mentioned that you would want to import technology. I'm wondering on the service side, what expertise you consider as being lacking as of today in the Korean market to push forward. For example, EPCs, OEMs, operation maintenance companies, engineering, fabrication know-how, and so on. I'm just wondering if the panel could elaborate a little more on what exactly is lacking today in Korea to push the market forward, both in solar and wind. Thank you.
Our speakers who are able to answer this question.
Hi, good question. I think Korea is pretty self-sufficient in terms of the technical capabilities across renewable energy. So let me start with that. Having said that, on the technology side, where we see some room to achieve better outcomes is really pushing, for example, on a solar farm, the designs to optimize output and efficiencies. I think Daniel referred to it as, no longer trying to push the cost down, but to potentially spend more money to achieve a better outcome. So there's things like DC-AC balancing, optimizing designs and procurement to achieve a better outcome per dollar, rather than just reducing the absolute dollar amount. In other sectors like wind, where I think there could be some improvements to the final outcome would be in the measurement of wind and in the specification of the turbines. And I think that becomes more relevant in the offshore wind space because it is a new sector. And then as we segue into offshore wind, I think there's a lot of areas where the lessons learned offshore, for example, with topographical surveys, the ground conditions related to the installation of piles and foundations, for example, are all areas where there could be value provided by international players with more experience offshore.
Okay, thank you so much. Thank you for, I think time is off now. I have to say goodbye for all of our audience and speakers. Thank you so much for your support and stay with us. I will see you next time and thank you so much.
Thank you.
네, thank you. 감사합니다.
Thank you.